try to solve the LeetCode problem sort colors. So this problem gives us that an array nums n and objects has the color red, white, and blue sorted in place so that the objects of the same color are adjacent with the colors in the order red, white, and blue. We will use the integers 0 and 1 and 2 to represent these colors. Okay. So the point of this problem is to not use the library sort function. So it's very tempting to just, just return array dot, well, I guess array dot sort, something like this in terms of pseudocode, but we cannot do this. So one method that you can use to sort this in one pass is to use 3 pointers. So we're going to call these 3 pointers low, medium, and high. And let's call that L, M, and H for short. So if I look at the example problem, let me just write this down for you guys. Nums is equal to 2, 0, 2, 1, 1, 0. And we know what we want this to be equal to, right? We want all the zeros to be one place, so we want 0. We want 0, 0. How many ones? We got 1, 1, and then we got 2, 2, right? So we want to transform this somehow without using an extra array. So one approach would be simply to count the number of zeros and ones and twos, create a separate array, and add them. So let's say, so you can just use a hash function and say, okay, I found 2 2s, I found 2 1s, and I found 2 zeros, and you can simply, well, it's pretty straightforward. You can add those things in a new value. But a better technique would be to use these 3 pointers that I've mentioned here earlier. So how that works is basically you set the low pointer at all the way at the beginning, and you set the high pointer all the way at the end, and the medium pointer. So think of this as the iteration pointer, the pointer that allows you to go through the entire array. And obviously we want to start from the beginning, right? Because medium has to go towards the right. We want to go from left to right. And so the key point in understanding how this 3-pointer problem works is that we want to delegate. So anytime we encounter a 2, we want to put that all the way at the end, right? So this will go, so if this was the beginning section of the array, the middle part of the array, and the end part of the array, right? We want to shift this 2 all the way to the end, right? Because it's going to be the biggest value. And anytime we see a 0, we want to put that at the beginning, right? So using this logic, eventually, if you put all the zeros at the beginning and all the 2s at the end, we're only going to be left with just 1s because we didn't do any swapping between them. All we did was simply switch the locations of the 0s and 2s. So that's enough conceptual talk. Let's try to see if we can, do it in action, because that'll be the most important part. Man, stop showing up. So we have 2, 0, 2, 1, 1, 0, okay? High pointer, low pointer, and medium pointer. So remember what I said. The moment we encounter, so when we encounter a 2, we're going to switch it with a high, because high is all the way at the end, right? We want to set this last values as 2. So we're going to switch wherever we were, medium pointer, with the H pointer. So what does this give us now? It gives us 0, 0, 2, 1, 1, 2, right? And because we already used up the high pointer here, we know that we want the next descending part to be the H, right? Because we already used up the 2 here, so H should not be here. So in the future, anytime we see a 2, we want to swap it with this location, and then we swap it again, and then and you see the pattern of how that with each time every 2s will be placed in the right position, because the moment we see a 2, it's going to be placed at the rightmost possible location, right? So let's go back. So where were we? So remember how we said that the moment we have swapped it with a high value, we decrement the pointer, right? So we have high here now because we're going to replace things with high. And, you know, medium is still here. And medium is here, right? So let's see. So when it's 0, we know that it's already in the right location, right? Because same logic as 2, 0 is always going to be placed in the leftmost position. So if we've already placed things in the leftmost position, L is going to be shifted, right? Because we want the next possible location from the leftmost to be the left, to be the 0. And we want M to also increment because M is simply the continuing pointer, right? So M is going to be here because M will simply continue because we want to look for either 0s or 2s, which are the values of interest. So this is again, so when it's 0, we just swap it with the low and medium, right? So it's 0 again, right? So all we're good. Now we continue this to low and M. And now what we have is 2. So remember what we said with 2, we want to switch this medium pointer, swap this with the high pointer, 0, 0, 1, 1, 2, 2, and decrement the high pointer. So the high pointer is going to be here, low pointer is still here, right? Because we only swap it when there's 0, and medium pointer is going to be here. Oh, and look, okay, it's 1. So whenever so 1 is interesting because that makes it seem like it's part of the array. So 1 is interesting because it's not 0, but it's not 2 either. So what do we do when we count? So 1 is simply we just continue onwards because we don't want to do anything special with it. And so this is 1 right now, right? So what we do is we don't shift the leftmost because shifting leftmost means we found the 0. If we shift L when we find a 1, that means that if we encounter a 0 later, it's not going to be in the leftmost possible position. So all we do is move the M. Okay. And H, and once again, it's 1 again, right? So we don't really do anything. And so M is now here. So when M is greater than H, we're done with the sorting because remember, H is the last possible position where 2 could have been placed, but if our medium pointer, which tells us the iteration of the array, then that simply means there are no more 2s available for us to swap, which means all the 2s are here, all the 0s are here, and all the 1s will be in the right position. And that essentially is the logic to solving this problem. I hope you followed through, and now let's just get on with the coding.